Hello everyone. In this session we are going to discuss worksheet questions based on ray optics and optical instruments. We'll enter into what is the refractive index of the material of a double convex lens having radii of curvature 5 cm and 10 cm of focal length of 20 by 3 cm. Let us write the given data. R1 is equal to, let me take another color. R1 is equal to 5 cm, R2 is equal to 10 cm, focal length MIAV is equal to, see, focal length focal length he has given, focal length F is equal to 20 by 3 cm and all are in centimeters, and refractive index we have to find out. We have double convex formula as 1 by F is equal to mu minus 1 into 1 by R1 plus 1 by R2. This is for double convex. Let us substitute 1 by F. 1 by F. It is 20 by 3. 1 by F is equal to mu minus 1 into 1 by R1, 1 by 5 plus 1 by 10. Already signs are applied in the formula. You no need to put again. Then here mu minus 1 into this is LCM 10 or 10. 10 will go 2 times and it will come as 1 time. So it will be here 3 by 20. Yeah, 3 by 20 into 10 by 3 is equal to mu minus 1. So 3 will go, 0 will go, 1 by 2 is equal to mu minus 1. So mu is equal to 1 plus 1 by 2, which is equal to 1.5. Refractive index 1.5, option A. Refractive index has no units. This type of additional points will come if you learn things from teacher's voice. Okay, so that is the difference between studying from the book and learning from a teacher's voice. Additional things will come. Associated things will be taught. A convex lens focuses an object 20 cm from it on a screen placed at 5 cm away from it. A glass plate of refractive index 7 by 5 of thickness T is equal to glass plate of refractive index 7 by 5 and a thickness T is equal to 1.4 cm is inserted between the lens and the screen. What is the distance of the object from the lens so that the image is again focused on the same screen? Image should come on the same place. So what should be the object position that he is asking? We'll do this type of problem like this. Actually, initially, let me draw a picture for you. This is the lens. We have actually in the syllabus thin lenses. Now it is object is placed at 20 centimeters. U is equal to 20 centimeters. And image formed at 5 centimeters. Image formed at 5 centimeters. V equal to 5 centimeters. This is normal thing. So focal length he didn't give. Let me find out focal length first. That is 1 by V minus 1 by U equal to 1 by F because it's a lens. So 1 by V value 5 minus 1 by minus 20 because left side measurements are negative. So it will be 1 by 5 plus 1 by 20 equal to 1 by F. So 20 is LCM, 20 is LCM, 25 4 times of 4 plus 1 is equal to 1 by F. Usually people will forget reciprocaling. Don't forget reciprocaling. Implies F is equal to 20 by 5. That means 4 are, yeah, 25 will go 4 times. And in 20, this will go to 4 centimeters, isn't it? 20, 20, 1 time 1. So 5 will go 4. So F is equal to 4 centimeters. Okay. Now, this is 4. 4 plus 4, 8. That means beyond C is the object. Object is beyond C. Between C and F is the image. Yes, right. Now next, another color. Yeah. Now there is a glass slab placement. Glass slab will bring the object, will bring the image closer. Actually, we will try to bring closer. How much closeness it is going to take up? How much closeness it is going to take up? The shift by slab. Shift by slab is, that shift is equal to, or x is equal to t into 1 minus 1 by mu. So that is T thickness 1.4, okay, 1.4 into 1 minus 1 by mu 7 by 5. I'll write that 5 on the top. So it is 2 by 7, 1.4 into 2 by 7, that is equal to 0.2 twos. 0.2 into 2, how much? 0.4. 0.4 shift. So new position. So new image distance at the same place he wants, right? It is going to shift. What is the distance of the object? What is the distance of the object from the lens, so that the image again focused on the screen? It is shifting by 0.4. So that we have to cancel. That means 5 minus 0.4, that is equal to 5 minus 0.4, that is equal to 4.6 centimeter, right? Yeah. Now this you take as V dash, and you can go again 1 by V minus 1 by U is equal to 1 by F, same thing. So this is 1 by 4.6 minus 1 by convergent rays. Yes, U is equal to, we have to find out, and 1 by F is 4 centimeter. So implies we are going to get around roughly 30.7. Yes, 30.7 centimeter is U value. Okay, so that you can feel. Next, an object is placed in front of a spherical concave mirror between the focal point and the radius of curvature. Object is placed in front of a spherical concave mirror, concave mirror at the focal point and the radius of curvature. Radius of curvature and the focal point. That means here is the object. That means it between F and 2F. This is nothing but 2F, F and 2F. Then image will be beyond C. Whenever image is beyond C, it will be inverted, it will be real, and it is magnified. So inverted, real, magnified, where is that? Inverted, real, farther than radius of curvature from the mirror. Looking correct only, but let me read all. Inverted, virtual, closer to the focal point. No. Upright, real, further, first only, last. Inverted, real, closer than the radius of curvature. No. So first option is correct. Correct. Yeah. A screen is placed 90 centimeter from an object. Screen is placed 90 centimeter from the object. 90 centimeter from the object. Screen and object distance it is. Screen and object distance. I'll write like this. The image is formed by using convex lens twice on the screen by putting the lens at two different locations separated by 20 centimeters. Okay, this is Newton's formula. We have to use 20 centimeters. Double placement. The focal length of the lens is approximately, focal length is equal to how much? This is, object will be here, screen will be here, and lens is placed here, you can get the image. If lens is placed here also, you'll get the image. And this separation is 20 centimeter he gave, and this is L, we will call L equal to 90 centimeters he has given. Yeah, and he is asking focal length. So that we are going to have this formula. That is L square minus x square by 4L. L square minus x square by 4L. That is equal to 90 square minus 20 square by 4 into 90. So roughly it will be 21.38 centimeters. So you are going to have answer as A. Next. What minimum separation between two objects a human eye would be able to resolve? That is only called resolving angle. If the eye pupil diameter is equal to, diameter of the pupil is equal to 2 mm, and the two objects are 2 meter away, 20 meter away, sorry, from the eye. Assume human eye to be equivalent to a convex lens. Consider the average wavelength of light is 600 nanometers. So he is asking the minimum separation between the two objects. We have resolving limit as theta is equal to, or theta greater than or equal to 1.22 lambda by L. Theta is nothing but y by L, right, or y by d. So in this you can substitute simply and you can have, this is lambda by d is better for you, lambda by d. This is diameter or aperture. Yeah, I'll write in a different way because both symbols will give you a confusion. So this is A. Yeah, y is equal to 1.22 lambda L by A. Some people will use capital D instead of L. Some people will use capital D, but I will use a different symbol because small d capital D will give you a confusion. This is lens correction 1.22, lambda 600 nanometers 10 to the power of minus 9, and L is equal to 20 meters by A value is 2 mm into 10 to the power of minus 3. Roughly it will be 7.32 mm. Position of final image formed by the given lens combination from the third lens will be at a distance of, all the focal lengths are given and the separations are also given. So the basic formula for this is P is equal to P1 plus P2 minus D P1 P2 is the formula for the combination of lenses separated by certain distance. Or if you have a problem in using such a big formula, then you can go for individual methods. That is, object is placed at 30 centimeter. Object is placed at 30 centimeter. And image formed by the first lens, V1 I will call, image formed by the first lens with a focal length f1 is equal to, with the focal length f1 equal to 10 centimeter he gave. So 1 by V1 minus 1 by U1 is equal to 1 by f1. I am doing for the first one. 1 by V1 is equal to 1 by f1 is 10, and here minus 30, so plus will come this side minus 30. So it will be 30 is the LCM. So this will go 3 times, this will go 1 time. So it will be 2 by 30. 2 by 30 means 1 by V1 it is. So V1 is equal to reciprocal 30 by 2, which is equal to 15 centimeter for the first one. It falls at 15 centimeter, right, for the first one. Now we need to go for the second lens. That story is, see, first lens is forming image 15 centimeter from it, but within 5 centimeters only second lens is there. So object for the second lens is equal to 15 minus 5 is equal to plus 10 centimeter. And V2 is the question mark and F2 is, he has given minus 10 centimeter. So 1 by V minus 1 by U is equal to 1 by F 2. So 1 by V2 we have to find minus 1 by U2 10, that is equal to 1 by minus 10. So it will come 1 by V2 is equal to minus 1 by 10 and plus 1 by 10. So it will be 0. So V2 is infinitive. That means final rays are parallel. Parallel rays whenever falls on the third lens, then they will be converged and formed image on the focus. Focal plane I can call, focal plane. So the distance is, focus is 30 centimeters, right? 30 centimeters is the focus. So final image or final focal length is 30 centimeters. There only it is going to form 30 D. Next, point object O is placed on the axis of a cylindrical piece of glass of refractive index 1.6. As shown in the figure. Appear to be one surface of the glass piece is convex with radius of curvature r is equal to 3 mm. The point appears to be at 5 mm on the axis viewed along the axis and from the right side of the convex side. The distance of the point object from the convex surface is 1.6 I noted and r equal to 3 noted. The point appear to be at v is equal to 5 mm noted on the axis right side of the convex. The distance refractive indices are there, mu2 is equal to 1. Okay, fine. So we have the formula mu2 by v plus mu1 by u is equal to mu1 minus mu2 by r, and r value negative we have to substitute in this case. And on substitution, mu2 1 by v value 5 plus mu1 1.6 by u value object is placed at, okay, that only we have to find, and mu1 minus mu2 1.6 minus 1 by minus 3 mm, all are in mm. Okay, so then solving for u, we are going to have a equal to 4 mm. Yes, you can. Next, at what distance from a biconvex lens of the focal length f, at what distance biconvex lens of focal length f must be placed an object for the distance between the object and the real image be minimum? Distance between the object and the real image be minimum. Great. See, if you put in between C and F, then it will be beyond C. If you put between beyond C, that will be between C and F. Then where can you expect the minimum distance between object and the image that we want? Yes, you are right. That is 2F only. If you put here 2F, then that image also comes at 2F, and the minimum distance between the object and image is 4F. Yes, you are right. This is minimum distance. So object must be kept at 2F. A thin convex lens of focal length f made up of crown glass is immersed in a liquid of refractive index mu L, and mu c is the refractive index of crown glass. The convex lens now is liquid refractive index is greater, then convex lens behaves in opposite sense. It behaves like a diverging lens. So its focal length will be negative. Convex lens longer focal length, convex lens shorter focal length, divergent lens. So it behaves like a divergent lens. That's what. Because whenever a lens is immersed in a difficult, that means denser medium, then it behaves in opposite sense. Convex will act as diverge, convergent lens will act as divergent, divergent lens will act as convergent. Three thin lenses are combined by placing them in contact with each other to get more magnification in an optical instrument. We have three lenses in contact. That means P is equal to 3P1 and focal length is equal to F by 3, F1 by 3. So 3 centimeter focal length will become by 3, that is equal to 1 centimeter. That is equal to 1 centimeter. Yeah. Next, and he is asking normal adjustment. Normal adjustment means the final image at D. So M is equal to 1 plus D by F. 1 plus D by F. 1 plus 25 centimeter by F is 1. So that is 1 plus 25. That is equal to 26 magnification. So option B. Two lenses of powers P1 is equal to minus 1.75D and P2 is equal to plus 2.25D. Okay, placed in contact, the focal length of the combination. So net power is equal to, you can add them. So it will be, here 1 is plus, 1 is minus. So subtraction takes place. So it will be 0.50. D positive came. Subtraction takes place. Why? Because 1 is plus, 1 is minus. So that is equal to 0.50 will give you power. Power is nothing but 1 by F. So F is equal to 1 by 0.5 meters or 100 by 0.5 centimeter. 1000 by 5. 200 centimeter. A light wave has frequency n is equal to 4 into 10 to the power of 14 hertz and wavelength lambda is equal to 5 into 10 to the power of minus 7 meter in a medium. The refractive index of the medium is equal to, light wave has a frequency 4 into 10 power 14. Okay, wavelength 5 into 10 power minus 7. The refractive index of the medium is equal to, actually you need to find out the velocity. velocity v is equal to n lambda, right? N lambda. So that is equal to 4 into 10 to the power of 14 into 5 into 10 to the power of minus 7. So it's going to become 5 4s are 20 into 10 to the power of 14 minus 7 is 7. That means 2 into 10 to the power of 8 meter per second. Now refractive index is equal to C by V, 3 into 10 power 8 by 2 into 10 to the power of 8 is 1.5. Refractive index is 1.5. Glass. PQ represents the wavefront AO and BP. AO and BP are corresponding to rays. Okay. Find the condition on O for constructive two rays. Okay. Constructive interference at P. Constructive interference at P between BP and reflected ray of OP. BP, OP. Yes, wanted to have a constructive interference. To have constructive interference, crest should come on to the crest, trough should be on trough. So phase difference must be 0 or 2 pi multiples of 0, right? So yeah, in order to have that, the rays should come to P in constructive way. So 2d cos theta is equal to lambda by 2 because one reflection is taken at O. So not n lambda, lambda by 2 only. So cos theta is equal to lambda by 4d. Lambda by 4d. So option will become B from simple geometry. The focal length of a spherical mirror made up of steel is focal length of a spherical mirror. F is equal to 150 centimeter. If the temperature of the mirror increases by 200 Kelvin, temperature of the mirror is increases by 200 Kelvin, the focal length becomes, focal length F dash is equal to how much? And you know, coefficient of linear expansion alpha is equal to 12 into 10 to the power of minus 6 per degree Celsius. So what is the relation between the temperature and the focal length? Focal length have the relation with radius, and radius is related to temperature. So think as focal length directly depends upon the radius. So you can take like this, F dash is equal to F of 1 plus alpha delta theta. So 150 into 1 plus alpha value 12 into 10 to the power of minus 6 into delta theta 200. So you are going to write it as 12 2s are 24 into 10 to the power of minus 4 plus 1 into 150. So it's simplified as 150.36 roughly, yeah, 150.36. All options are looking together. D, it's D. Yeah. 2 point sources S1 and S2 are 24 centimeter apart. S1, S2 24 centimeter apart. Where should a convex lens of focal length 9 centimeter be placed in between them so that the images of both sources are formed at the same place? Images of both the sources should form at same place. Placement of the convex lens should be at which place? Here is one source S1, another source S2, and where I have to put such that 2 will give you at the same place. Good question. So here, if you put the lens on one side only, then you never get both the images at the same place. So you never. So what you need to think is you have to put the lens in between so that one will form a virtual image at one place. Obviously, virtual image will be on the same side. The other ones will be real image at the same place. So suppose if you are taking X, the other one will be 24 minus X. 24 minus X. Now, for its virtual image and its real image will coincide. So Y value y is equal to y or y distance for virtual image distance, virtual of S1, and same y is equal to real of S2. Then you can write two equations for them, that is object is equal to x and image is equal to at y. Maybe this side, same side. So you can take y minus and x also minus. Then focal length f is equal to 9 centimeters as usual. Write an equation 1. That is 1 by v minus 1 by u equal to 1 by f. Again, u is equal to 24 minus x. 24 minus x. And image will be v is equal to this side. So y, and I'm thinking in a reverse way. Okay, f is equal to 9 centimeters again. Then equation 2. Solve the both by finding y value. Y is equal to roughly 6 centimeters. 6 centimeters will come. What's that? Yeah, 6 no? Total distance 24. 24. Let me verify the calculation. Yeah, I change it to 6 centimeters. 6 only correct answer. Next. An image is formed at a distance 100 centimeters. V equal to 100 centimeters from the glass surface. When light from point source in air falls on a spherical glass surface with refractive index mu equal to 1.5, the distance of light source from the glass surface is 100 centimeter. The radius of curvature is equal to, maybe it is like this. So object is 100 centimeter distance, image is again 100 centimeter, and radius of curvature, everything is given. So mu2 by v minus mu1 by r is equal to mu2 minus mu1 by, this is u, wait, this is u, mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Mu2, this is mu1 which is equal to 1, mu2 which is equal to 1.5 he gave. So 1.5 by 100 is equal minus 1 by minus 100 is equal to 1.5 minus 1 by r value positive. That only we are going to find. So r will come as, why should I waste time? 20 centimeters will come, right? So 20 centimeters. So option A. An equiconvex lens made up of glass of refractive index 3 by 2, equiconvex made up of refractive index 3 by 2, has focal length f in air, okay, it's completely immersed in water of refractive index mu2 is equal to 4 by 3. The percentage change in focal length will be FL is equal to how much? We have a formula, FL is equal to mu minus 1 by mu g with respect to water minus 1 into F. So he is asking percentage change in focal length. That means FL by F minus 1 by F into 100. This one we need to change, we need to calculate. That is FL minus F by everything we need to write. Okay, so we'll do one thing. FL by F is equal to, first we'll do FL by F, mu minus 1. Mu minus 1 means 3 by 2 minus 1 by mu z by mu w. Separately we'll calculate. Mu z by mu w equal to mu z value 3 by 2. Mu w value in denominator I have to write. So 3 by 4. Majority cases 3 never cancel. 9 by 8 only will come. 9 by 8 minus 1. So this is going to become 1 by 2 in the numerator. 1 by 2 by this is 1 by 8. So these two together will become 1 by 16. 1 by 16. So 1 by 16 minus 1 by F value F only. Okay. That must be changed. F value we have in any other way to calculate? No. F value we have no other way to calculate. 1 by 1 minus 16 by original I have to take, right? So Shortest way is, it is taking long way to simplify, so I would like to do in a different way. Why should I follow that and this? I'll follow in a different way. We want FL minus F by F, right? So I'll do one thing. This is FL by F minus 1. On both sides I want to do 16 minus 1. Then this will be FL minus 1 by F is equal to, this is 16 minus 15, minus 15 by 16. Now into 100 I'll do. Percentage change in F is equal to into 100 minus 15 by 16 into 100. So 4 table will go 4 times, 4 table will go 25 times. Okay. Now 25 15s are 15 15. Oh, is it correct actually? I did any mistake in this? Let me check once. 2. So 1 by 2 correct only. This is 8. 9 minus 8 by 8. 1 by 8 correct only. Okay, here I did the mistake. Here I did the mistake. That is the problem. So one small mistake with lack of concentration, you need to pay a lot. No regrets. So this is not 1 by 16. Okay. Yeah. 1 by 2 into 8 by 1, which is equal to 4. Yeah, right. So FL by F is equal to 4. Both sides minus 1. FL by F minus 1 equal to 4 minus 1. So FL minus F by F is equal to 3. Into 100 is equal to 300%. Wow, wow. So 300% is the answer. Because positive only we got. For a point object, which of the following always produce virtual image in air? Concave mirror many times gives real image, only once virtual image. Convex mirror always gives virtual image. In air he said, okay, plano-convex lens, plano-convex, biconvex. We have only one option, convex mirror. Convex lens of focal length L is placed somewhere in between the object and the screen. Convex lens of focal length L is placed. Convex lens. Okay. The distance between the object and the screen is S. The numerical value of magnification produced by the lens is M. Then focal length of the lens. Magnification, distance between object and the screen. And in these terms, we need to tell the magnification. Here, suppose we kept the object at some place so that U plus V is equal to X. And magnification M is equal to F by F minus U, and that is equal to F minus V by F. Yes, F minus V by F, F minus V by F. So taking two equations with this, taking two equations for magnification M is negative. Taking two equations, magnification M for real image. So minus M, F by F minus U. So F minus U is equal to F by minus M, and U is equal to F minus will become plus F by M is equal to U. So this is F of 1 plus M by M, that is equal to U. Similarly, you can get V, and then adding one that and this to X, then obviously you are going to have focal length F is equal to mx by m plus 1 whole square, isn't it? Mx by m plus 1 whole square. Yes. Next, focal length of a convex lens will be maximum for, focal length of a convex lens will be maximum for focal length, green light, blue light, red light, yellow light. So par will be, or directly anything you can think anything. So which will bend more? Which will bend more? Which color will bend more? That will have least focal length. Which will bend less? Will have more focal length. So obviously red color will bend less, red color will have more focal length. No sir, I want like a formula. Then F is equal to, you have lens maker's formula. 1 by F is equal to mu minus 1 into 1 by R1 minus 1 by R2. And you know mu is equal to lambda by lambda naught by lambda. So mu inversely proportional to lambda, and inversely proportional to focal length. So focal length directly proportional to lambda. So more lambda, more focal length. This is theory. Simply you can feel that less bending one will have, suppose one has bended like this, one has bended like this. Then you think whose focal length is short? This one is having short focal length, this is having long focal length, isn't it? So less bending one will have long focal length. So here red light is the answer for it. Yes. The size of the image of an object which is infinity, which is at infinity, and as formed by the convex lens of focal length 30 centimeter is 2 centimeter. The concave lens of focal length 20 centimeters is placed in between convex lens and the image at a distance 26 centimeters from the lens. The new size of the image is. So you should be patient enough to solve such problems. Very patiently we have to do this kind of sums, lengthy sums. The size of the image of an object which is at infinity, object is at infinity, is formed by a convex lens of focal length f is equal to 30 centimeters. Object is at infinity, then image also will be formed at 30 centimeters focal length only, and hi image, that is equal to how much? 2 centimeters. Now if a concave lens of focal length 20 centimeter, concave lens of focal length 20 centimeter is placed between the convex lens. Let me draw first initial picture. A convex lens, object is at infinity, so finally it forms image at 30 centimeters, whatever is the focal length. This is 30 centimeters, 30 centimeter from here, and which is the focal length, or V. Okay, now he kept one concave lens. At what distance? 20 centimeters between convex lens and the image, at a distance 26 from the lens. This is 26. That means this is obviously 4, right? That means object distance is equal to plus 4 for the lens. And image, he is asking the new size of the image. Okay, then 1 by f minus 1 by y minus 1 by v minus 1 by u. Yeah, 1 by f, 1 by minus 20 equal to 1 by v minus 1 by u value is 4, plus 4 only, and I want to have 1 by v. 1 by v is equal to minus 1 by 20 plus 1 by 4. So this is going to become 20 LCM. In 20, 20 will go, so minus 1 plus 4 will go, 5 times are 5. So it is going to become 4 by 20. 4 by 20 means 1 by 5. That means V is equal to 5 plus only. That means from here onwards it is going to form this here. Okay, at 5 centimeters it is going to form. Okay, so magnification for this is, magnification is equal to V by U, that is equal to Hi by H naught. V 5, U 4, Hi height of image, we have to find height of object 2 centimeters, because it is going to form a size of 2 centimeters, he said. So 2 will go 2 times, so Hi is equal to 2.5 centimeter. Option B. UU. Should be careful while doing that such lengthy problems. If the refractive index from air to glass is 3 by 2, refractive index air to glass is 3 by 2, and that of air to water is 4 by 3, and the ratio of focal length of a glass lens in water and in air. Okay, focal length, ratio of focal length of a glass lens in water and in air is equal to mu minus 1 by mu g with respect to water minus 1. So that is equal to 3 by 2 minus 1 by mu g with respect to water is equal to 9 by 8 minus 1. So it is going to become numerator 1 by 2, denominator 1 by 8. So it is 8 by 2, that is equal to 4. 4 is to 1. The following figure shows a beam of light converging at point P. When a concave lens of focal length 16 centimeter is introduced in the path, convex length beam as placed by the dotted line, such that OP, okay, becomes the axis of the lens. The beam converges the distance at a distance x from the lens. Okay, the value of x will be equal to value of x will be. So here initially rays are converging at P. That means you can take P as the object. So object is at what distance? 12 centimeter. Of course it's positive, you need to consider because right side only. And focal length is 16 centimeter, but it's a concave lens, concave. So minus 16 centimeter. Then final image will be formed at lens formula is 1 by V minus 1 by U is equal to 1 by F. 1 by V minus 1 by U is equal to 1 by F. So 1 by V is equal to 1 by 12 minus 1 by 16. It is going to become 14, 12 and 16. 48 is LCM. 48, just a number which will go in the two tables. 12 will go 4 times, 4. 16 will go 3 times. So it will be 1 by 48. That means final image will be formed at 48 centimeters. So that is only the x, whatever he is asking. So diverging lens will diverge the rays to form it to some other place. Of course, this is what you call myopia concept. This is myopia concept. Think wisely. The refracting angle of a prism is A, and refracting angle of the prism is A, and the refractive index of the material is cot A by 2. Cot A by 2. Okay. The angle of minimum deviation D minimum is equal to how much? Refractive index mu is equal to sin A plus D by 2 by sin A by 2. This we have, and he is asking to take this as cot. Cot means cos A by 2 by sin A by 2. Isn't it? This one can be like this. Sin A by 2, sin A by 2 will go. So this is sin A plus D by 2 is equal to cos A by 2. What kind of changes we can do with this? Sin theta is equal to some cos theta. Sin theta 1 is equal to some cos theta. Both can be converted into sine functions like this, I think. This is sine of 90 minus A by 2, right? 90 minus A by 2 will be obviously cos A by 2. Now first one and last one are sine functions only. A plus D by 2 is equal to 90 minus A by 2. Then A plus D is equal to LCM 180 minus A, and 2A equal to 2A plus D. 2A plus D is equal to 180. So we want D equal to 180 minus 2A. 180 minus 2AB. So that mathematical thought immediately should come. That's yours. A certain prism is found to produce a minimum deviation of D minimum is equal to 38 degrees. Okay. It produces a deviation of 44 when the angle of incidence is either 42 or 62. What is the angle of incidence when it is undergoing minimum deviation? Okay. Deviation D is equal to 44 if angle of incidence is equal to 42 or 62. That means one is I1, one is I2. So I1 plus I2 is equal to A plus D. We have the formula. That is 42 plus 62 is equal to A plus D is 44. So 42 plus 62, 104 minus 44 is equal to A. So A is equal to 4 will go 60 or 60. Now in this case angle of incidence I1 plus I2 is equal to A plus D minimum, because I1 I2s are equal in case of A minimum. 2I. So I is equal to A value 60 and this is 38 by 2. So no guessings. In physics you shouldn't guess, you have to do the calculation. This is 98 by 2. 98 by 2 means 45 plus 4 49. Yeah. An object is placed at a distance of 20 centimeters. U is equal to 20 centimeters from the pole of a concave mirror. Focal length 10 centimeters. F equal to 10 centimeters. The distance of the image formed is equal to V is equal to question mark 1 by V plus 1 by U is equal to 1 by F. 1 by V we have to find plus 1 by U minus 20 and 1 by concave mirror. F value negative minus 10. So 1 by V is equal to 1 by 20 minus 1 by 10. That is equal to 20 LCM 1 minus 10 LCM 2 times. So minus 1 by 20. So V is equal to on the left side only 20 centimeters. That is its meaning. Minus 20 centimeters. Plus 20 is there, minus 20 is there. Be careful. Take care. A linear object of height h is equal to 10 centimeter. Height of object is kept in front of a concave mirror. In front of a concave mirror of radius of curvature r is equal to 15 centimeter. Concave, right? Yes. At a distance 10 centimeter, the formed is linear object of height 10 centimeter. Okay. In front of a concave mirror of radius of curvature 15 centimeters at a distance 10 centimeter. Okay. U equal to 10 centimeters. It implies focal length is equal to 15 by 2. That is equal to 7.5 centimeters only. And object is placed at 10. That means it is concave and its focal length is 7.5 centimeters is focal length. And 2F will be 15 centimeters. This is 2F. So object is at 10. Object is at 10. That means it is in between F and 2F. So image will be beyond 2F. Image will be beyond 2F. So it is magnified, inverted and real. Magnified, inverted and real. Option B. Magnified, inverted and real. Next. During scattering of light, the amount of scattering is inversely proportional to the dash of wavelength of light. Fourth power of wavelength of light. This is Rayleigh scattering law. And focal length of a convex lens is 20 centimeters. F is equal to 20 centimeter and refractive index mu is equal to 1.5. It produces an erect, enlarged, magnified. If the distance of the object from the lens is erect you want. Whenever you want erect, it should be between F and O. It will be between F and O. That means focal length 20. So between 0 and 20, before 20 only, below 20 you should be. So this is the answer. If between F and O only, it will give you erect, magnified. Erect means virtual image will come, virtual. This is simple microscope concept. A plain glass plate is placed over the various colored letters. A plain glass plate is placed various colored letters. Okay, the letter which appears to rise more. Which one appears to be raised more? That is apparent shift is or depth. Depth is equal to apparent depth equal to h by mu. So mu value is more for violet. So it's in the denominator. So what happens? HA will be apparent depth will be small. HA is smaller for violet. This is large, right? Yeah, small for violet. And apparent depth will be more for red, because red is having less wavelength. So as per this, you can have the answer as more elevated means it should have small depth. So that is the sense. So violet will become the answer. Hereafter, we will continue with wave optics worksheet questions. In an interference pattern of Young's double slit experiment, at a point we observe n is equal to 12th maximum, 12th. For a monochromatic light source, lambda 1 equal to 6000 angstroms. And next, if lambda 2 is equal to 4800 angstroms, then which order we are going to observe at the place? Suppose this is central maximum or 0 bright, we will call it as 0 bright. Here onwards at a distance y, suppose we are observing 12th maximum with lambda 1 wavelength. Then at the same place y, which order will come if it is lambda 2. That is the thing. So y is fixed here. Y equal to nl lambda 1 by d. The same y ml lambda 2 by d. So l by d gets cancelled. M lambda 2 is equal to n lambda 1 implies m is equal to n lambda 1 by lambda 2. That is equal to n value 12, lambda 1 6000 by lambda 2 value 4800. Two zeros will go, and m is equal to 12 fours, 4 will go 15 times. So 15th fringe will come, 15th order will come, right? Yes, next one. The angular width of the fringe in a double slit experiment is beta in degrees is 0.2 degrees. Okay. And on the screen at 1 meter away, L equal to 1 meter, I used to write capital L instead of capital D. The wavelength of light used, lambda is equal to 600 nanometer. Okay. The change in angular width of the fringe if the entire experiment or measurement system is immersed in water. Actually, these things are not at all required. See, nu beta is equal to beta dash beta naught by mu. This is the formula for it, as lambda is going to change because lambda dash will be lambda by mu. That's why. Because of that, this will happen. So beta is equal to, what is beta naught? 0.2 by mu value 4 by 3 because it's water. So 3 into 2 by 4 into 10, because I don't want to deal with point numbers, will be 2. 3 by 2 is 1.5. 1.5 by 10, that is 0.15 degrees. Is 0.15 degrees. 0.05 is given. That means he may be asked change. Yeah, we need to notice that. That means change of angle he asked. Change of angle. That is beta final minus beta initial. That is equal to beta final 0.15 minus 0.5. 0.15, 0.2. 3 by 2. 3 by 2 is 1.5. 0.15. Okay. So initial final one 0.15. Initial one is 0. So it will be 0.05 degrees. Only difference we need, right? That's why. Magnitude you may be. Next. Amplitude of the wave resulting from superimposition of three waves. x1 is equal to a cos omega t, and x2 is equal to 2a sin omega t. x3 is equal to root 2a cos omega t plus pi by 4. First these two I want to simplify. Because both are cos functions and they are differed by a phase of pi by 4. Both are cos functions. So what you call, you can first two also will be easy, 1 and 3 also will be easy. Let me find out easiest one for you. Okay, first two only better, what I feel. First two only better. First two, later the third one can be added. Then only can be easily with a less time we can add. So those two. Complete x is equal to x1 plus x2 plus x3. But here first we will do, first step, x1 plus x2 we will add. That is equal to a cos omega t plus 2a sin omega. So multiplying and dividing with the square root of a square plus b square, that is a square plus 4a square. Nothing but root 5a. Multiply and divide. Multiply and divide. So what happens? It will become multiply and divide. A is anyway common only. Why should we multiply again? Just only with root 5 is enough. Why a? Yeah. Just numbers we can take. This is 1 and this is 4. So it will be 5. Fine. Now multiply and divide with root 5. So a by root 5 cos omega t plus 2a by root 5 sin omega t. into root 5. So I multiplied and divided with this. So x1, 2, we added these two, that's why. A can be taken out, root 5 also taken out. So it will be 1 by root 5. 1 by root 5, some value. What that value? Yeah, that 5 value I may take as some, here cos function is there, and resultant also I want cos only. So I will write it as I'll take as cos function, so it will be somewhat easy. This is some cos 5, which is nothing but 1 by root 5. 1 by root 5 is cos 5, and it is cos omega t, plus it is sin 5. Sin 5 is nothing but, here I will mention that sin 5 is equal to 2 by root 5 and cos 5 is equal to 1 by root 5. So that is equal to sin omega into sin omega t. So it will be a root 5 into cos a cos b plus sin a sin b is nothing but cos omega t minus 5 I can write, because that is the definition for x1 and 2. Now you can go for x1, 2, 3. That means a root 5 cos omega t minus 5 plus this third one root 2a cos omega t plus pi by 4. You can use your trigonometric identities. Why to waste my time, and I can go for, and I would like to give you the final answer. The remaining simplification you can do, right? Yes, it will be root 5a, isn't it? Root 5a is the net displacement or net amplitude, A resultant. A resultant is equal to root 5a. I changed it. What would be the angular separation between the consecutive bright fringes in Young's double slit experiment if blue-green light of wavelength 400 nanometers, lambda is equal to 400 nanometers. The separation between the slits D is equal to 0.001 meter. Okay, we have beta is equal to lambda L by D, right? Now tan beta is equal to tan beta. Tan beta means, see what you call this one, tan beta. If it is beta, angle one if you want, angular one if you want, this is actually beta length and this is L. So beta by L, this will become angular width. Tan beta degrees is equal to beta by L, which is equal to lambda by D. So angular width beta degrees is equal to lambda by D, which is equal to 400 nanometers 10 to the power of minus 9 by 1 into 10 to the power of minus 3. That means 4 into 10 to the power of minus 3 minus 6 and 2 more, so minus 4, right? This will be radians. In radians only will come. Whenever you divide length with length, you never get degrees, you will get in radians only. So 4 into 10 power minus 4. Whenever you divide length with length, you are going to have radians only, remember. On using red light, lambda R is equal to 6600 angstroms. In Young's double slit experiment, 60 fringes are coming, 60 fringes are observed in the view. If you use violet light of 4400, the number of fringes observed will be, so M is equal to how many? So for the same given distance, Y is equal to NL lambda by D, NL lambda by D. For the same distance, if you take NL lambda by D, I can call, implies N lambda is equal to M lambda 2. So N1 6600 is equal to M lambda 2 4400. So 0000 will go. So M is equal to 60 into 66 by 44. 11 table 6 times, 11 table 4 times. So 15 6 are 15 into 6. M is equal to 15 6 are 90, yeah? Yeah. Two beams of monochromatic light of intensity 64 MW Monochromatic light of intensity watt per meter square, isn't it? Anyway, 64 units first I'll write. Intensity I1 is equal to 64 and I2 is equal to 4. Interferes constructively to produce intensity of 100 milliwatt. Intensity will be in watt per meter square. Okay. To produce resultant intensity is 100 units. Okay. If one of the beam is shifted by an angle theta, okay, maybe phase difference, what I feel, the intensity is reduced to 84, I resultant became 84. The magnitude of theta is, okay, the magnitude of theta is, right. The first one need not to consider into account what I feel. I can use this formula. I resultant is equal to I1 plus I2 plus 2 root I1 I2 cos theta. I resultant is 84 and I1 is equal to 64, I2 equal to 4 and 2 root 64 into 4 into cos theta. Yeah. So cos theta is equal to 1 by 2 implies theta equal to 60 degrees. The limit of resolution of a telescope is theta is equal to 2.5 into 10 to the power of minus 7 radian. If the telescope is used to detect light of wavelength lambda is equal to 500 nanometer from the star, the diameter of the objective diameter d is equal to how much? Resolving limit of a telescope and the resolving limit formula is theta is equal to 1.22 lambda by a. So let us substitute 2.5 into 10 to the power of minus 7 equal to 1.22 into 500 into 10 to the power of minus 9 by d. D only he is asking, right? Okay, d or a, whatever. Okay. Let me use the same symbol for us. So this is a. So a is equal to or d is equal to whatever. 1.22 into 500 into 10 to the power of minus 9 by 2.5 into 10 to the power of minus 7 is equal to 2.44 meter. So you can use 244 centimeter. I am multiplying with 100. In Young's double-slit experiment, mth and nth order of the two fringes are at P on a distant screen with monochromatic light sources of lambda 1 is equal to 400 nanometer and lambda 2 is equal to 600 nanometer are used separately. The minimum value of m and n respectively, mth order and nth order. Okay, m lambda 1 is equal to n lambda 2 if you take, then lambda 1, okay, m by n is equal to lambda 2 by lambda 1. Lambda 2 600 by this is 400, that is equal to 3 by 2. That means 3 comma 2 reverse ratio you need to take up. Yeah, next order will be 6 and 4. A parallel beam of light of intensity I0 is incident on a coated glass plate. If 25% of the incident light is reflected, if the incident light is reflected from the upper surface, okay, and 50% of light is reflected from the lower surface. Let me take a picture for it. I'll draw here. Okay. Yeah, normals I want to draw. Okay. Now lighting. Yeah. A parallel beam of light of intensity I0 is incident on a coated glass plate. If 25% of the incident light is reflected, 25% is reflected, okay, the upper surface, and remaining will fall on here. In this, 50% is reflected at the bottom surface, the lower surface of the glass. The ratio of maximum and minimum intensity of the interference region of the reflected light is interference, maybe this one and that one both are going to, okay, this one again will come out with the 25%. So this one and this one will interfere. I think so. Okay, this one we'll analyze. Okay, from this what I can give you is, let me take a different color. Yeah, suppose I naught is given. Yeah, he only said I naught is given. 25% of the incident light is reflected. That means 25% of I naught is I naught by 4. I naught by 4. So first reflection, intensity after first reflection, intensity of first reflection, I1 is equal to I naught by 4. Next, here this is remaining 75%. That means 3/4 of I naught it will be, because 25% reflected means remaining will come here, and it's a not absorbing. You can feel like that. Among it 50% is reflected. That means half. That means 3/8 I naught it will be. Of 3/8 it will be refracted. In the refraction I think he didn't give anything. So it will be 3/8 only. 3/8. In the refraction he didn't give anything. So total 3/8 I naught will come. So after second reflection, intensity after second reflection. Sir, you people can use dittos, but you won't accept us to use dittos, because we want to save time and you have to practice writing. So 3/8 I naught it will be. Now we can go to our color. That is, result I max by I min is equal to, I max by I min equal to root I1 plus root I2 by root I1 plus root I2 whole square. Plus will give you maximum and minus will give you minimum of amplitudes. Actually these are all sum of amplitude by difference of amplitude whole square. So it's going to become I naught gets cancelled. Okay, root I naught root 1 by 4. Root 1 by 4 will be 1 by 2 plus root 3/8. Root 3/8 in the options also root 3/8 I am watching, so I am not cancelling that, by this is 1 by 2 minus root 3/8 whole square. So option A, though a narrow slit, through a narrow slit of width, slit width, narrow slit single, so A equal to 2 mm, diffraction pattern is formed on the screen kept at a distance 2 meter, distance L equal to 2 meter from the slit. The wavelength of the light used is lambda is equal to 6330 angstroms. Okay, normal slit screen. Then the distance between the two minima on either sides of the two minima or second minima, two minima on either side of the central maximum. Maybe this is central maximum, this is one minima, and this is another minima. So gap between two minimas he may be asking. Yeah, gap between two minimas. Fine. That is maybe 2y1, right? 2y1 is equal to 2 into y1 is equal to lambda L by A. So that is 2 into which diffraction it is? Okay, we'll see. And lambda value 6330 into 10 to the power of minus 10 into L value 2 meter by A value 2 into 10 to the power of minus 3. Wow. So this will give you 1.27 mm. So yes, yeah. This is the end of the session. We'll discuss another chapter problems in another session. Bye. Keep on practicing. Be focused.